Hello students, welcome to Nilachal Polytechnic. Myself Amrendra Mishra. Here in this video class, I am going to explain about the hydraulic coefficients and the relationship between them. In the earlier video classes, we have already studied about that there is a orifice which is a small opening at the bottom side of the tank. We are considering the flow of liquid is taking place to the orifice. First of all, we are taking a tank inside which we are going to find out that what is the head of water. At the bottom of the tank, we are going to make a orifice. Now we are going to allow the water to flow through the orifice. Now we have to find out that what is the vena contracta point. Consider that up to while the flow of liquid takes place, we have to measure that at which point the flow lines are parallel, straight, and up to that point, that section is known as your vena contracta section. Now we are going to find out that what is the value of your hydraulic coefficients. Coefficient means that these are the only numbers which are giving the value of the ratio of actual value to theoretical value. We are having, there are three types of hydraulic coefficients. One is your coefficients of velocity, second one is coefficient of contraction, and last one is your coefficient of discharge. Let's consider about coefficient of velocity. Coefficients of velocity means that is the ratio of actual velocity of water at the vena contracta point to that of the theoretical velocity obtained from the orifice flow parameter. Let's consider V is the velocity of water at the vena contracta. Already you have know that the velocity which is obtained by the orifice that is V is equal to 2gh root over h is known as your height of water in the tank. So the theoretical discharge means that is the velocity of liquid coming out from the orifice by using the formula that is 2gh root over. Now the coefficient of velocity is expressed in terms of Cv. Now Cv is equal to actual velocity of fluid at vena contracta divided by theoretical velocity of fluid. Cv is equal to V divided by square root of 2gh. Let's consider about the coefficient of contraction. Coefficient of contraction, it is the ratio between the area of jet of water at the vena contracta section to that of the area of orifice through which water is flowing. If we are considering that area of vena contracta is A subscript C and area of orifice as A, then we can find out that mathematically Cc is equal to AC by A. While considering about the coefficient of contraction, we are measuring the area of jet at vena contracta and the area of jet before the orifice diameter. So if d is the diameter of orifice, then the area of orifice equal to pi by 4 d square, and we have to measure both the area of the orifice and area of the jet of water at the vena contracta. Now let's comes to the coefficient of discharge. Coefficient of discharge is the ratio between actual discharge to that of the theoretical discharge. We know that discharge is equal to area into velocity. So it is expressed in terms of CD. Now CD can be given as mathematically theoretical actual discharge divided by theoretical discharge. So actual discharge means actual velocity of the fluid into actual area of the fluid at vena contracta divided by theoretical velocity into theoretical area. Theoretical velocity means 2gh root over. Theoretical area means that is your area of orifice. Now we can find out that what is the relationship between Cc, Cv and Cd. Now according to coefficient of discharge, Cd is equal to Q by actual by Q theoretical. Now Q actual is equal to actual velocity into actual area divided by theoretical discharge. Theoretical discharge means theoretical velocity into theoretical area. Let's separate the two terms, actual velocity by theoretical velocity, actual area by theoretical area. We can find out that V by 2gh root over into AC by A. It is clear that V by 2gh is equal to coefficient of velocity, that is Cv, and AC by A, that is your coefficient of contraction. So Cd is equal to Cc into Cv. Now in the next class, video class, we will have to study about that what is a nose and what is a weir.